Hello everyone. In today's video, I'm going to show you how to calculate daily net radiation from CoAgMet weather data. And we know that net radiation is a really important parameter in the calculation of reference crop evapotranspiration and a bunch of other type of calculations that we might do for ag meteorology or microclimatology. So most weather station networks don't report net radiation, and so it's important to learn how to calculate that yourself. Recall that net radiation is equal to the net shortwave radiation minus the net longwave radiation. And I'll mention here that we're following the ASCE standardized method. So basically, we need to download the weather data from CoAgMet, then do some calculations and create some new columns till we arrive at our new calculated value for net radiation on a daily basis. So step one is to go to the CoAgMet site and go to the data access page if you're not there already. And it looks like this when you start, and we need to make some changes to get the data that we need. Let's start by date. We want it in CSV. We want to include headers. We want the QC data, that means quality controlled. We want the units to be metric. We want daily time step. Let's get the data over, let's pick like 2020, and let's go from the beginning of April to the end of September. So basically the growing season for that year. We want the date format to be in the ISO 8601. We want Mountain Standard Time. Okay, that all looks good. We need to pick a location. We want a single location. Let's go to our Fort Collins, or let's go to RDEC. That's the experiment station next to Fort Collins, Colorado. And then finally, we have to pick which variables we want to download. And I'm going to start by checking none. The variables that we need to calculate net radiation are max and min temperature. We need the vapor pressure. We need solar radiation, and we need the calculated value of clear sky radiation. It's very nice that CoAgMet provides that. It saves us a lot of time. Now, that's all we would need to calculate net radiation, but we're going to use this same sheet to calculate reference crop evapotranspiration. So I'm going to add a few more variables just to grab them while I'm here. And I'm going to get the maximum minimum relative humidity, the average air temperature. I'm going to get rainfall, okay, in terms of liquid precipitation, and I need the wind run, okay? And finally, I'm going to go ahead and get the CoAgMet calculated values of reference crop ET for both the tall crop and the short or grass reference, okay? So that's my final configuration. And then I just hit open. And you should see all your data coming in. So you see the headers across the top and all your comma separated variables. Then I hit Control S. And this will allow me to save this. Okay, I'm going to save this in my downloads folder. I'm going to call it RDEC 2020 daily. Okay, and I'm going to save that as a CSV. So change the subscript, put .csv here, and that'll make things a little easier for you. We don't want it to save it as text, although we could recover from that if we did. And I'm going to hit save. And that should save that, right? So if I go over to my downloads folder now, I'm going to hit refresh here. There we see the data I just downloaded, RDEC 2020 daily CSV, okay? Most of us have our computer set up that if we double click a CSV file, it'll automatically open in Excel. That is if we're using a lot of different computers. If not, just start Microsoft Excel and open this file. Okay, and it should come in and go ahead and put itself into columns. And it did, right? So here we see our data now on a daily basis. Sitting here, looks pretty good. One of the a few little housekeeping things that I do before I get too far along is you'll notice that it has two header rows, and in general, that's not a good idea for Microsoft Excel. This causes problems when graphing and doing things later. Do notice though, before you delete it, just remember that CoAgMet downloads solar radiation and clear sky radiation as watts per meter squared, right? That's not a good variable for us to use. So we're going to have to change that. But I just wanted to point that out before I delete this row. And also, when you notice when data often comes in with this importing method, it just defines all the variables as type general. It's a good idea to go ahead and change these to what they really are. So this is a date, and all of these are numbers. And that just helps sort of clean things up. Okay, so we've got a nice little data set started. Now we need to start adding columns to help us move toward uh, the calculation of net radiation. So I made a little, as I showed earlier, a little cheat sheet that I can use. And here's the little cheat sheet now showing one of the first things we need to do is convert RSO and RS into megajoules per meter squared. So if I pull that up here, let's create a couple of new variables, RS in megajoules per meter squared per day. And we want to also create a column for RSO to do the same thing. And to do that, so here's solar radiation in watts per meter squared, and I want to convert it to megajoules per meter squared per day. So it's equal to, I grab that column, times the number of seconds in the day, and divided by 1 to e to the 6 to put it into megajoules, okay? That looks pretty good. Do the same thing here. All right, once I have those, I can just block them and double click that little green box there. That looks good. I'm also going to convert that into a number. There we go. So now I've got my global irradiance and my clear sky global irradiance, both in units of megajoules per meter squared per day. Now, the next step is to calculate net shortwave radiation. So net shortwave, RNS, if you recall, is just equal to our global irradiance measured by CoAgMet times 1 minus the albedo of the crop. And the standard value for the ASC E approach is 0.23 for albedo. So if we do that, there's our shortwave radiation. Double click that, it fills it in. I'm going to change the units back to a number. I don't know why it's showing so many decimal points, but there it is. Great. So that's net shortwave. So we've got half of our net radiation formula already done, right? So we're in good shape. And again, most of this is on the cheat sheet here in case you need it. Now we need to calculate the net long wave. And remember that one, that calculation is quite a bit harder. We need to calculate the air temperature in degrees Kelvin and make an adjustment for cloudiness or the amount of humidity that's in the atmosphere, right? That's downwelling radiation toward the surface. So if we go over there, the first step in that process is to calculate the cloudiness factor. Okay, that's how we can tell how cloudy it was that day. And remember, it's often used FCD for that, and it's basically just the ratio of the measured short wave divided by the clear sky value. So it's equal to 1.35 times the measured value divided by the modeled value, okay, minus 0.35. Now, the closer it is to 1 means it was a really clear day, and the closer it is to 0 means it was really cloudy. And if you run that down through there, you can see values are between, should be between basically 0 and 1. And you can see that every once in a while, like down here on this particular date, it's August 8th, we got a negative value. Okay. We don't want that. In this growing season, it looks like maybe we'll, oh no, here's another one. May 24th. Okay. So we really don't want those negative values in there. We want to constrain it between 0.05 and 1. Okay. And if you look at the notes on that or look at the ASCE reference, it talks about that. So we can modify this formula to do that using Excel tools. And basically, it kind of looks like this. I'm going to cut and paste here just to make it a little bit easier. Well, maybe not. I'll just type it in here. So we're going to write a new version of this formula that says I want the maximum of between 0.05, that's our, and the minimum of this number. Seems kind of strange when you see it, but if you think through it, it'll kind of make sense. And if you need to go back and review the your Excel skills and study the max and min uh, formula. Hopefully I got it right there. Let's see. Okay, it worked. That's a good sign. Let's see if those negative numbers go away. Okay, and remember one of those was right here. Yep, right here. You can see it replaced that negative number with 0.05 and looks like it replaced some that went greater than 1 with 1. Okay, so that's a pretty important step. So again, let me flash that up there so you can see the formula. It's right here. And that solved that problem for us. Okay, great. Now we're finally ready to calculate the net long wave radiation, RNL. And this is a pretty, like I said, it's a complicated equation. If you remember, let me pull it back over there again. It looks like this, okay? So it's going to have a lot of terms in it. That's the Stefan-Boltzmann constant. This is our maximum air temperatures in degrees Kelvin, though, and these other terms, right? So I just need to create an Excel formula. So here you can see I skipped forward just because it takes me a lot of time to type that in. But here you can see the formula that I used, okay? And to calculate the daily net long wave, right? So you see the Stefan-Boltzmann constant, you see the air temperatures being used here to get finish the Stefan-Boltzmann. You see the vapor pressure being used here to, and finally our cloudiness factor, right? And so in this case, you can see what the net long wave looks like. So finally, we're ready to calculate the net radiation. Remember, that's RNS minus RNL. Okay, and there it is, and boom. All right, so finally we have the calculation of net radiation. So even with the assistance of the clear sky calculation by CoAgMet, it still took quite a bit of work. We could make a plot of that. What it might look like here. Maybe the scatter plot's a good way to go. And we can see it there. So basically, you can kind of see an arc there, numbers, a lot of stuff between, 10 and 16 megajoules per meter squared per day. But a lot of variation, right? Because even in a place like Colorado, there's significant cloudiness. So that's what causes that. So now we have our net radiation term, and it's useful by itself, but it really comes into its own when we use it to calculate reference crop evapotranspiration, and we'll do that next.